Hello guys, today we are going to discuss about the unit 2 topic conformal mapping. A conformal mapping is a mapping from one plane to another plane as you can see it in a given image. Now, what is conformal mapping? Conformal mapping is a mapping from if C1 and C2 are the two curves in XY plane, Z plane, that means a complex plane where Z is equal to X plus iota Y, and respectively C1 dash and C2 dash are the curve in UV plane, W plane, or we can say that W is a F of Z plane. Then the transformation of XZ plane to UV plane preserving the angle, magnitude and sense is called conformal mapping. This is the Z plane, this is X direction, this is Y direction. Similarly, with respect to these curves C2 and C1, we have a curve with the same relation over here in a plane U and V. This is FZ plane, or we can say that W plane. Corresponding to C1 and C2, we have C1 dash and C2 dash. If the angle, sense as well as the magnitude is preserved, then the mapping is called conformal mapping. The application of conformal mapping is in the field of fluid mechanics, electrostatics, heat conduction, as well as in biomathematics and many more. In your syllabus, there are few more type of mapping like translation, as it is known by the name W is equal to Z plus beta. By this transformation, a figure in Z plane, that means in XY, are displayed or translated in the direction of the vector B in W plane. Similarly, rotation, W is equal to e to the power iota theta Z. By this transformation figure in Z plane are rotated through the angle theta. If theta is greater than 0, then it is anti-clockwise, or if theta is less than 0, then it is clockwise. Similarly, stretching, W is equal to AZ. In this, we can zoom in as well as zoom out in W plane. Inversion, W is equal to 1 by Z. Yes, this is the last lecture problem which I have given you, and few of the students asked me to solve this problem. Over here we have integration Z square minus 2Z over Z plus 1 whole square and Z square plus 4 dz. Over here we can say that this integration is equal to integration of, for the curve C1, for the curve C1 is Z square minus 2Z. I am writing this small z because my 2 and z are almost similar, and Z plus 1 whole square upon, this can be written as Z square plus Z square plus 4. Now this is the dz and this is the function of fz, plus integration for second curve C2 curve is Z square minus 2Z over Z square plus 4, this is fz, over Z plus 1 whole square dz. The circle of this problem is mod of Z is equal to 10. That means this should be a plus 10 to minus 10 minus 10 iota to plus 10 iota. So the pole according to the for curve, for C1 curve, poles are Z square plus 4 is equal to 0, that means Z square is equal to minus 4, that means Z is equal to plus minus 2 iota. So we can say that for the first integration for C1, Z square minus 2Z over Z plus 1 square upon Z minus 2 iota into z plus 2 iota dz is equal to integration of z square minus 2z upon z plus 1 square into z minus 2 iota upon z plus 2 iota dz plus integration of z square minus 2z upon z plus 1 square into z minus 2 iota z plus 2 iota upon z minus 2 iota dz. Over here this is the fz and over here this is the fz. That means you have to put the value of this according to the Cauchy integral formula in this function and multiply by 2 pi iota as per the formula of Cauchy integral formula. So you can solve the first C1 curve. Now for the value of C2 curve is z square minus 2z over z square plus 4 upon z plus 1 whole square dz. Over here we just use the formula of Cauchy integral for the derivative, that is f n a is equal to 1 over factorial n over 2 pi iota integration with respect to curve of fz upon z minus a to the power n plus 1 dz. Now comparing from this Cauchy integral formula for the derivative, what we have, this is split into 1 plus 1, that means n small n is equal to 1. So what we can say that, this 2 pi iota is multiplied to the left term, then we have 2 pi iota into f of single derivative 4.a is equal to factorial of n, that is factorial of 1 is equal to integration of fz over z minus a to the power 2 dz. Now by comparing this value, what we have, small a is equal to minus 1 and f of z is equal to z square minus 2z upon z square plus 4. Now to solve this value we have to differentiate this value, this fz, according to the formula, this formula we required f dash z. For f dash z is equal to d by dz of z square minus 2z over z square plus 4. For the differentiation rule we have z square plus 4 and differentiation of this value is 2z minus 2 minus, now this term is same, z square minus 2z and differentiation of denominator is 2z upon z square plus 4 to the power 2. Substituting the value of f dash z for z is equal to minus 1. By putting this value we have minus 14 upon 25. Minus 14 upon 25. Now substituting this value in terms of given problem, integration of z square minus 2z over z square plus 4 upon z plus 1 whole square dz is equal to 2 pi iota into minus 14 by 25 upon factorial 1. So this is the required solution for the given integration. By adding this part as well as the previous integration part, you will get the solution. Thank you. For any doubt or any query, feel free to contact me at this number.